Light and electromagnetic radiation comprise one type of wave phenomenon. The other wave phenomenon is sound. Physically, sound is radically different from light. Light is electromagnetic energy, and sound is elastic pressure waves. Despite this, both sound and light have common properties such as amplitude, wavelength, and modulation of either through time. Just as light can convey a rich information stream, so too can sound. Here we want to consider what sound is. Here's the simple answer. Sound is work, and therefore energy. Sound is generated by doing oscillatory work on a surface that can be made to vibrate, either a flat surface or the round surface of a vibrating string. This makes sound amenable to a thermodynamic analysis. This is important to understanding sound as a biological phenomenon because the energetics of sound production has a rather direct relationship to fitness. Specifically, the more efficient the generation of sound, the more likely it is that the signal will be received by an intended target, which often is a prospective mate. When it comes to producing sound efficiently, we have learned a great deal about how to do this from musical instrument makers and audio engineers. You'll not be surprised to learn that animals were way ahead of us in this. As you watch the videos to follow, I would like you to keep three things in mind. First, just what is sound? How is it generated? How is it propagated? And through what kinds of materials can it propagate? Second, how can we treat sound as an energy balance problem? How can we use this as a guide to increasing the efficiency and reach of sound produced by animals? And third, what is the evolutionary significance of managing the energy balance of sound production?